Okay, morning, boys and girls. This is your math teacher, Daniel. And in today's lesson, we're going to learn about vector addition from vectors in calculus. So, by the end of this section, you're going to be able to add vectors using both the parallelogram law and triangle law, and you're going to know how to represent vector and vector addition geometrically and algebraically. Also, you're going to learn how to calculate the magnitude and direction of resultant vectors. So, before we get into this topic, let's try to figure out what is a vector addition and why it is important. So vector addition in simple word means to add one vector to another vector and get a brand new vector. So vector addition in scientific way to say it is to combine two or more vectors into a single resultant vector that captures their total effect. This is essential in physics, engineering, and navigation. So think about the examples that in real life which we're going to use the addition of factors. So for example, when we're walking uh, across a river, so we have to consider the we have to consider the current and the speed of our human, and so we have to add those two up, and we're going to get a new direction, or we should say a new speed, or we can say it's the ground velocity. So how do we exactly do the addition of factors? Let's see this example. So, or we can say the method, first method. So this is, as we can see, presenting the triangle method, which means obviously you can see a triangle here, right? But how do we get the triangle, and how exactly did we get the result by forming a triangle? So as we can see, the former, or the reactant of A, vector A and B. So if we want to add A and B up, then we have to make them tail to head. That's how we form a triangle in the vector addition. So the result we get is vector R, and it's the other side of the triangle. So in a word, triangle method means to connect vector's head to another vector's tail, and then the third side of the triangle will be the resultant. So let's move on to another method, and that it is the parallelogram method. So parallelogram method literally means you form a parallelogram to get a resultant uh, by using the two vectors, or we can say we add up two vectors to get a new resultant vector. So as we can see, the red one x1 and the blue one x2, if we move x2 directly to the top, make it tail to head with x1, and then we can form another triangle. Or in another way, we can say the parallelogram is actually made of two completely same triangles. So in another word, parallelogram is another form of triangle, and triangle is another form of parallelogram. It's convertible. So x1 and x2 are connected tail to tail, and that's the point of making a parallelogram method. And I personally, I think it's the most useful method. So in a word, Parallelogram method means to connect vector's tail to another vector's tail, and the diagonal will be the resultant. So let's go on and move on to the subtractions. So let's say if we want to make an a minus b, we can convert a minus b into a plus negative b, which means opposite vector is the opposite direction but the same magnitude. So the magnitude of b is equals to the magnitude of negative b. And let's see, so the c is equals to a minus b, which equals to a plus the negative b. So we can just simply switch the direction of vector b to an opposite direction. So this is a more direct diagram to show you how exactly we would do it. So if we want to know what the result is when adding up a and b, we can just simply use parallelogram and form a parallelogram. So a plus b equals to d1, which is the longest vector here. And if we want to know what is a minus b, we can just switch the direction of b, where we can use the parallelogram, and the d2 is a minus b, which is a plus negative b. And now let's do some workouts. So question 1, a small airplane is flying to north at 150 kilometers per hour. When it encounters a wind of 80 kilometers per hour from the east, what is the resultant ground velocity of the airplane? So let's say the north, if it's heading north, it means it's heading upwards, right? In 2D in 2-dimensional. And if the wind is from the east, and then it means it's actually blowing from the east side. So we can use make them two vectors. Let's say the airplane's velocity is vector a, and the wind velocity is vector b. So we have to make an addition of vector a and vector b to have the observed velocity from the ground, which is a new vector. So the result is 80 square plus 150 square, and square root the addition equals to 170.03, and the tangent alpha equals to 80 over 150, which we get 28.07. So another workout. The magnitude of x equals to 7 and magnitude of y equals to 24. If the angle between these vectors is 90 degrees, so which means they're perpendicular, so determine x plus y, the addition of x plus y's magnitude, and calculate the angle between x and x plus y. So if we want to know the angle between x and x plus y, we need to know what is x plus y. So in this diagram, we can see how we form the x plus y, which is the magnitude of x squared plus the magnitude of y squared. We get x plus y's magnitude equals to 25, and then we can get tangent theta equals to 24 over 7, and the tangent of the theta equals to 73.74 degrees. And question 3, AB and AC are two unit vectors with magnitude 1. So with an angle of 150 degree between them, I'll calculate AB plus AC's magnitude. So first of all, we have to know that it is given that the magnitude of AB equals to the magnitude of AC equals to 1. So we can just simply do a parallelogram, and then we can get the result. So the result, we need to use a so we need to use the, what we call that, the tangent, the calculation. So basically it means u plus v, the magnitude square equals to u square plus v square minus 2 2 times magnitude of u times magnitude of v times cosine theta equals to 1 plus 1 minus 2 times 1 times 1 times cosine 30 degree, which equals to 2 minus square root of 3. And then we can get the magnitude of r equals to 0.518. So this is the end of the class, and now I'm sure you have learned how to add the vectors up by using the parallelogram law and triangle law. And now you can know what geometrically we use the addition of vectors. And now you can know that the calculate of the vectors using their magnitude and direction. Thank you, kids. You're doing a great job.